Good afternoon, everyone. Thank you for attending today's webinar on what inspectors should focus on. The webinar will be recorded and the recording is available to all attendees on the Code Adoption Toolkit with the drop-down of recordings. If there are any issues with audio, please write me in the chat. My name is Erica DeLello and I am a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by the Mozingo Code Group. Shauna and I have been working with the Colorado Energy Office for a couple of years now to provide trainings just like this one. So we do have a few more in this series, as I've shown on the screen, but there are also is a large library of previously recorded webinars available on that Code Adoption Toolkit. So if you've got a question on something, there might already be a webinar for it. So if you have any inquiries about what trainings we have done, feel free to reach out to me on that as well. We do also offer tailored group trainings or technical assistance for jurisdictions that are updating I-codes. So if you are looking at moving to the 2018 or 2021 I-code suite, we're here as a resource. So please feel free to reach out. Then, as I've mentioned before, the Code Adoption Toolkit, most of you are probably familiar with it, but the one new offering that we do have on there is the Colorado Codes Helpline. And with Excel Energy, CEO is sponsoring this hotline to help anyone on addressing any comments or questions for the I-codes or REACH codes. So if you, for example, if you're from a jurisdiction, you're a plans examiner and have a question about code applicability or a plan review item, feel free to submit a ticket, attach whatever files you need for context, and a subject matter expert like Shauna will respond in just a few days' time. So you can access this through the Code Adoption Toolkit or through the link that I have posted up here. I do suggest bookmarking it as an easy get-to resource. So just a couple of other housekeeping items before I move on is that throughout the webinar, we do want to encourage questions. So please use that Q&A function. And I'll let Shauna know at the end. There is also the ability to raise your hand and ask a question directly, and we can unmute you. And then lastly, there's a survey window that pops up following the webinar. So if you could please take a moment to provide feedback and we can continue to improve on these webinars or provide new resources. So today our presenter is Shauna Mozingo, and she's the president of the Mozingo Code Group, as well as being a plans analyst and inspectors for jurisdictions over the last year, over years. She's provided code adoption assistance, trainings to code officials, builders, energy raters, and designers. She's a past president of the ICC Colorado chapter and has served on the IECC Code Development and Correlation Committees for the 2018, 2021, and the 2024 code cycles. So with that, Shauna, I'll stop sharing my screen and you should be able to share yours.
All right, let's see how this works out for us. Hopefully I get you the right screen. You seeing my screen now?
Yep, looks good.
Right, perfect. All right, well, there is a lot to get through today because we're going to cover some hot topics of inspection for residential and commercial. I guess I would say that we're going to really focus on a top 10 type of approach when we look at these inspections. So because we only have an hour, right? And so we want to make sure that we touch on those high impact items. If you are interested in talking about envelope or mechanical or lighting or something in more detail, more residential or more commercial, shoot us an email and we're happy to provide some training to your jurisdiction or maybe add some webinars to the next cycle. But this is what we're working on today. All right, so what I like to look at here is residential. We'll start with residential first. So the Department of Energy, a lot of people have gone through and created this top 10 approach because we know that as inspectors, it's really hard to look at everything. And so what, if you're going to look at something, what are the most important things to look at? You know, so in the envelope, air sealing, of course, is number one residentially. It's beginning to become number one commercially too, but we'll talk about that in a minute. Roof insulation, we're at that top of that house where a lot of the climate, a lot of the weather is hitting us. We need that roof insulation. Windows for sure. Wherever we have a window, we don't have insulation, right? And so we want to make sure that the window is good enough to meet the values of the insulation. And then wall insulation, those are our top envelope. That doesn't mean the rest doesn't matter. We're just saying, hey, if you got to focus on something, let's focus on these things first. Mechanical, the right size of equipment, the right efficiency of the equipment, ventilation, ventilation, ventilation. We're going to hit on that a lot today. Duct design, duct tightness, we'll talk about that. And controls, shutting things down when we don't need them. Same with lighting. The lighting efficiency of the light bulbs, they're pretty much there already. And so it's really about shutting them off when we don't need them so that we're not running that electricity all the time. All right. One thing that I've learned as an inspector is as I go through and I'm walking through a house, especially on a rough or a final, oh my gosh, there's so much to remember. And so how do I get these things to stick into my head? What I've learned is if I understand how my building works, then I'm more apt to remember to look for certain things in the field. And so I just have a couple slides here on air movement so that we can better understand why air tightness is such a huge deal in residential as you're looking through it. So wherever air can get into the building, so can moisture, pollutants, and other things. So we really want to keep the minimum, keep these air leakage to a minimum for the building's durability, air quality, and health and safety. Also, if you have a lot of air leakage in and out of the building, your mechanical system has to work harder because, you know, maybe it's 20 degrees outside, and if that air is leaking in, the mechanical system has to reheat it. And so we were trying to keep that mechanical system from not working as much. So there has to be more efficient ways to deal with this. And we just want to gain some predictability on our interior environment. So air moves just like water. I mean, it just needs a hole, and it just needs the right pressure, the right temperature, the right relative humidity. And so air can move. And like I said, anywhere air can get in, so can moisture. So it's important to understand why we say seal all of this, seal all of these holes, or make sure that the air barrier is sealed everywhere. And so air can move and bring with it a lot of different things. The building works with stack effect. So you have colder air at the bottom. As it warms up, it rises, and it's trying to get out all of those holes everywhere in the building. That's why we're really, strict about seal up that attic access or get tight around those can lights because that air is trying to get out. And so whenever air goes out, what goes out must come in. It's going to always try to pressurize itself or to keep a neutral pressure. So if air is leaking out somewhere, the house will draw air in somewhere else. And so with it, it'll bring whatever it brings with it, moisture, pollutants, cold air that has to be reheated, hot air that needs to be cooled. So that's why we're trying to keep this. This is just the normal way that air moves. So trying to make sure that that thermal envelope is tight. That's why there's requirements for a tight envelope. Now new requirements that the plans have to say all the air sealing details on there, and hopefully you're inspecting from those plans to show those details that they've called out. Something that I want to point out here, and I know you've probably seen this a bunch, but this is one place that I find in residential that we have a lot of problems, is about duct leakage and the thermal envelope leakage. So if we have, there's reasons why the mechanical code tells us to keep a tight duct system and to make sure that we keep the envelope tight. So if we think a lot of times that, oh, I need to keep tight ducts so that the air doesn't leak out, so that if I need 200 CFM out of this, out of these supplies in order to keep this room 68 degrees, then I'm going to bring back 200 CFM. I have to do supply equal return, right? So if I need 200 CFM, I don't want these ducts to leak so that I get the right amount of air there. Well, if the ducts leak, will I still get 200 CFM? Sure, I will, but the mechanical system has to work harder to get it there. So we often think about that when we are looking at duct systems and looking to make sure that they're tight and sealed. But something else that I want you to think about is also about a leaky duct, on whether or not, if you're trying to heat and cool this space up here, and you're supplying maybe 1,000 CFM to heat that hole upstairs, but if your returns leak and you're only bringing out 500 CFM, then you are overpressurizing the upstairs. You're blowing it up like a balloon. Well, the house, like I said, is always going to try to equalize its pressures within itself. So it will force air to come in somewhere else, right? So I'm forcing air out of this envelope in any hole that I have, and it will eventually make those holes bigger. And I'm sucking air in from outside, so bringing with it any moisture or any cold air that now I have to work harder. So it's not just about, excuse me, it's not just about getting the right amount of CFM to keep the room the right temperature. It's also about sealing those ducts so that I don't overpressurize or underpressurize any portion of the house, and make the building less energy efficient that way, by bringing in colder air or wrecking my thermal envelope. So there are different reasons why we're always saying, make sure that you seal those ducts. And so sometimes just remembering that when I'm walking through on a rough inspection or a final inspection, and I'm looking at, or on a mechanical inspection, and I'm looking at those ducts, knowing that there's more than a few reasons why we need tight ducts, it just helps me to remember to look for that. Look for all of that pookie on there, right? And we also want to make sure that we're not bringing in moisture into the house, because a lot of times we don't see that moisture till a long time after the building is up and operating, years afterwards, and people are sick and they don't understand why, because inside their walls is moisture that got in. And there's a lot of different ways that it can get in there. So we're really, I'm just trying to point out to you why the code is so strict about building a tight house and getting that envelope right, and making sure that we don't have a lot of air moving through those. If the air is moving through that wall, it's reducing the R value by going through the insulation. It's bringing with it any kind of moisture, cold air. Cold air might be, condensing on a colder, or, on a warmer surface, or a warm air might be condensing on a cold surface inside that wall, getting a lot of rot in there. There's all kinds of things that can be happening. So it's really important to be catching this at inspection phase. There's a lot of moisture sources. Bulk water, I might have rain hitting a wall and it's getting through, or a sprinkler system that's for some reason hitting the wall all the time. There might be snow up against my house that's going to melt, and I have bulk moisture. I have diffusion, where with just the right temperature, air can move through building assemblies like drywall and other things. And I'm going to get that moisture in there just from air leakage, air movement. So lots of ways it gets in there. Sometimes it's easy to see the moisture or the mold or the mildew on the surfaces. I have air that's leaking around a door, and it's cold air, and it's condensing on a warm surface here. And so I'm going to get this mold. So somewhere in here, there is an air leakage problem, right? Another thing with moisture is, the nice thing about air brings moisture. It can be, but air also dries moisture, right? So it's again about predictability. Where's the air coming from? I want ventilation If I had the proper amount of ventilation in this house, I wouldn't have this condensation. I need ventilation to keep that air dry and to keep these surfaces dry, but I need that air to come from a controlled source, not from the outside, that cold air hitting that warm surface or that warm air hitting that cold surface, right? So that's what the code is talking about. And we're really going to hit hard on ventilation when it comes to inspections. It's definitely the top 10. You always hear it, but build tight and ventilate right. So a couple things that you should be aware of as an inspector for residential. There is a new requirement in the 2021 that the inspectors really have, that we look for the flow rates for ventilation. So, you know, maybe the IRC says, according to the size of this house, we need 75 CFM running continuously. Now there's a requirement that we actually prove that that's what we're getting. And so there's a requirement for testing of the flow rates and a report that gets turned in. So most likely the building inspector or the mechanical inspector is not out there testing those flow rates and carrying this equipment around. Most likely you will be just collecting a report from somebody that's doing it. You know, we often require balancing on commercial, or some jurisdictions require balance reports on residential. We require duct testing and we get that report. We require blower door testing, we get that report. This is another report we're going to get that says, hey, this whole house was designed, and according to how it was designed, here's how much air needs to flow through there to keep it healthy, dry, safe. And so we want to make sure that we're getting that right amount of air. IECC doesn't really call for ventilation, it says you have to have mechanical ventilation. We can't rely on outside air just opening a window. It has to be mechanically ventilated, and then it sends you to the IRC for how to do it. So just a couple things as an inspector that are really important to note. It'll tell you that you can do a supply, exhaust, or combination system. So we'll look at each of those and what to look for. It tells you that the system has to have controls, and it has to have an override control. So what it's telling us is, if you look at the table, which we'll look at in a second, it'll tell you how much air has to be brought in. And that table, or it gives you an option for a formula to calculate how much air has to be brought in. That is at a fan running continuously, or a system running continuously 24 hours a day, right? So they also have the option to not run continuously, to run only part of the time. So if that happens, there's going to need to be controls. And so a lot of times plan reviewers aren't catching this, and the inspector really needs to catch the fact that those controls are installed. So if they say, oh, we're only going to run a quarter of the time. All right, where is that automatic control that will allow this system to only run 25% of the time? It's better not be an on-off switch, right? That the homeowner runs. We need that 25% of the time. The code says if you run 25% of the time, you have to quadruple the amount of ventilation than if you were running continuously. So we just need to make sure as inspectors we're looking for those controls, and that there's also an override control. So if there's a fire outside, or there's something or something going on, I have the ability to shut it off so I'm not sucking in all of that air with whatever system I'm using. The house, it gives you the option, like I said, for a ventilation rate that goes to the IRC mechanical section, and it tells you either do by the table or do by a calculation. It's based on how big the house is, how many people live in it, or at least how many bedrooms. And then again, an exception, you can run intermittently only part of the time as long as you have the right controls. That's where I see people putting in the right size exhaust fan or the right whatever system, but no controls to automatically make it run. And so just be aware of that. There's a bunch of different types of system. We can do an exhaust only system. What goes out must come in. So just keep in mind, this works fine for our climate. We have a drier climate in Colorado. And so it works. It's not the ideal, the tighter house you get to just be exhausting all of the time and not offsetting it with some return air, because whatever, if you're exhausting a bunch of air and not providing some return air, or some supply air, you could start doing damage to the thermal envelope. But it works here. You could put an exhaust fan, usually in a bathroom or something, put it on a timer and have it going all the time, because what goes, it'll exhaust out and then it'll bring air in. So you're really looking to make sure that somewhere in the house they have 1 or 2, however many exhaust fans that they need, based on how many CFM they are required, and that those have the right controls on them. There could be a supply only system. The supply, it uses a fan to pressurize the home, forcing the air in, and then it will exhaust out on its own. What comes in must go out. It kind of just the reverse. There's all kinds of different ways that people do this. It's kind of inexpensive and easy to install. It's usually like maybe a dedicated system, like a central fan integrated system, where the outdoor air is ducted to the return plenum of the air handler. Sometimes this works a little bit better in warmer climates than it does in our cold climates, but I do see people doing it here. It doesn't temper the air, so it's bringing in whatever air at whatever temperature, so it's not like a balanced or ERV or something, but it's just making sure that the supply is brought in, that you have the right dampers. You know, you're bringing the supply, you're bringing the outside air in and running it through. So just making sure you have the proper controls set up for that. A balanced ventilation system is great. We're going to force air out, we're going to bring air in. So what you're just making sure that you have, I mean, I'd love to spend time to go through all of these systems and how are they working, but it's important if somebody says they're doing a balanced system, that they have a system that's taking stuff out and they have a system that's bringing stuff in, and they're controlled, right? So making sure that they have exhaust and supply and controls. Then there's all kinds of different ways that people do it. You know, you have a central integrated supply, or you could just pair a supply with a fan. That's a least expensive probably way to do it, but it's at least you're taking the same amount of air out that you're bringing in, hopefully, if it's set up correctly. And then you have ERVs, and ERV is an option. When people think, oh, I have to have balanced ventilation, this is what they think. It doesn't have to be this. This is a little more expensive. However, it's an expensive upfront cost, but it also, you know, saves some energy over time because it has a heat exchanger where the air from outside gets run across that heat exchanger, and so it can temper the air that gets brought in. ERV, an energy recovery ventilator, will remove some of the moisture, where an HRV does not. But an HRV, which is a little bit cheaper, is good in our climate because we have a pretty dry climate. So just looking to make sure that wherever the ductwork is installed, it's insulated, it's tight, that you have, you know, that it's installed to manufacturer's install instructions, and you have the right controls to make sure that those are working. It's so important that ventilation work correctly. U factors, residential isn't as big of a deal. I mean, it is a big deal. The U factor of a window is so important because if you have a bad window, all of that heat is making it in and the air conditioner has to work, or all of that cold is making it through and the heater has to work. Wherever there's window, there's no insulation. And so making sure it's a good window that would equal out to if there were insulation in the wall. There's stickers on the window for the U factor solar heat gain. Pay attention in Colorado, in some of these climate zones now, U factor or solar heat gain that was never a requirement before is now a requirement in the 2021. So you're going to be looking at just at the U factor plus the solar heat gain on those stickers. So be sure you're looking for that. That there's a lot of requirements coming down in the future that will limit the amount of windows that you can have on a residential building and lower those U factors and solar heat gain coefficients. So it's good to learn about them right now. They make a huge difference. So I just throw this up here as an inspector. It's good to know what paths are available to somebody in the code for residential. And the main reason that I say that is because hopefully you're inspecting from the plans. And say the plans say that they're going to put in a 0.32 window, and you get out in the field and they're not 0.32. Does that mean you fail them and you make them put in the right windows? You know, if that was a prescriptive requirement, then maybe we, instead of failing, they have the opportunity to go back. They have the opportunity to work through all of these code change, or all of these paths of compliance. So if they start out prescriptive and they get to doing construction and it doesn't work, they have the opportunity to go change. Maybe they can go run a res check that allows, you know, some trade-offs in there for the building thermal envelope. And so maybe they're doing something above code over here and below code over here, but they equal out. And so they have the opportunity to go run a res check and see if they can make it still work. If they can't make it pass with a res check, they can get a rater involved and go performance and see if there's more things that they could trade off, or they could go ERI and even more things to trade off. So it's not just one way. So if they fail, not on you to tell them what to do, but there are other options that they could do. They don't have to yank it out and put in something new unless they go through all those paths and can't get it to figure out. Hopefully a lot of you are familiar with res check. One thing that I have noticed in a lot of residential studies that I do is that the res check is not making it into the field with the approved set of plans. This res check is letting us know if they're passing using this total UA trade-off. It's a path that they're allowed to use. And if so, it means they've gone through here and made some trades. Maybe they did better insulation to put in a worse window, or better window to put in worse insulation, or better insulation in the ceiling to put less insulation in the wall. There's all kinds of ways to trade, but it only is about the envelope. So it's important to know that a lot of times U factor is not something you find on the plan, or R value isn't something you find on the actual construction documents. A lot of times it's found in this report. This report is what you inspect off of for energy. So if I'm going through and I make sure that hopefully I open the set of plans, and somewhere in there is this res check, and I open it up and I see that, oops, going the wrong way. I just go through, you know, it tells me I have a flat scissor truss with an R49 insulation. That's what I'm going to look for, because they got it to pass using these values. Any other value, they either need to redo their res check to make sure it still passes, or they need to go a different path. You know, this tells me I have a wood frame wall at 16 inches on center with an R19 in it and an R2 continuous. Is that what I'm seeing in the field? Do I see the R19 in the cavity? Probably a bat. But it also says I have an R2. What's that R2 about? Do I have an insulated siding? Do I have a rigid foam board? What do I have on the outside of that building that's getting me an R2? If you're not seeing it, then they need to go back and redo the res check with what they really did to make sure they still passed, because they only passed by putting that R2 on the outside. So just really going through here, you know, did you see 0.29 windows on a vinyl frame? 0.29 windows. Just kind of going through here. This is what they said they were going to do, and this is how they got to pass energy compliance. This is what you should be inspecting off of. There's an inspection checklist that Res Check prints out that is kind of handy, because it really is based on, it's specific to each house based on what you chose through there. It'll tell you what to look for and all of the mandatory requirements in the code. And it's laid out by, you know, from framing and rough-in inspection all the way to final inspection. It's laid out in the order of construction, so it's kind of handy. Not that you have to use it, but some people like checklists. If they went performance, it's almost the same thing. There's software out there. It goes through and tells you, okay, how much did it cost to build this house? If I modeled it, how much will it cost in energy? And as long as it costs less than if you built it prescriptively, less than or equal to, you're fine. And the report is several pages, but it's just like a res check. It gives you what they said they were going to do. This U factor, this R value in the ceiling, this R value in the basement, this R, and you just need to make sure that's what you're inspecting off of, because that's where they made their trades. So just being on the lookout. Then there's the ERI path. that it's exact same software as that performance path. It just uses a Ervs score. So you're making sure that if they said that they were going to get a score of 45, they got a score of 45. It doesn't necessarily matter. What you're just really needing to make sure is that for your climate zone, so say you're in climate zone 5, if the max score you can get is 61, that they stay under 61. So they may have, when they turned in the plan, said that they were going to get a score of 45, but they might end up with a score of 60. They still pass, right? So that is okay, unless you have some amendments locally on a specific Ervs score. So that's kind of how you read those reports. Each report tells you what they said they were going to do in that house as far as R value and U factor, air leakage, and all of those different things. So be inspecting from those documents. All right, and then there's the 2021 residential brought in additional efficiency package options for, and so this is just saying if I went with prescriptive or res check, I have to choose one of these options to do on top of everything else the code required. So somewhere on the plans, it has to say what they chose, and that's what you need to be inspecting for, because this is what's getting them all the way to energy compliance. Without this, they're not all the way there. And so this is not something additional. This is to get you to full compliance. So if DOE said that the 2021 energy code was 9% better than the 2018, it's only 9% better if they do everything that they're supposed to do. And so instead of cranking the code down by 9%, they cranked the code down by 4 or 5%, and then gave you options of how to get the other 5%. So you can see they have to either, choose one of the options in there, which would be 5% better UA, like a better res check score, or 5% better heating or cooling, more efficient heating or cooling equipment, better water heating equipment, a ductless thermal distribution, a better duct system, along with a better thermal envelope, or a better blower door score and an ERV or HRV. So they have one of those options that they have to choose in order to get them into full compliance. So you just need to make sure that if they said, oh, we're going to put in a 5% better furnace, then that they're not getting in there with an 80% furnace, right? Because they said they were going to choose high efficiency. So just something to pay attention to on the plans to make sure they're getting all the way there. Make sure the thermal envelope is fully sealed. The air barrier must be continuous all the way around. So every joint, seam, penetration has to be sealed. That's something that we really have to be looking for on these plans. That's why the code calls for a blower door test. Most of the time as an inspector, you're not doing a blower door test. You're looking for that report that says in our climate zones that they got to 3 air changes per hour or less. And for those of you that are freaked out about it, I can tell you, I just looked at a study that I did last year for NASIO, where we looked at 126 houses, and we did, out of those, we did 64 blower doors. And out of 64 blower doors across the entire state on people that were on anything from the 2009 code to the 2018, out of 64 houses, only 8 did not pass. It's not that hard if you get the air sealing details correct. So that's important for inspectors to realize, that we don't want to get to the end and fail a blower door. So we really need to keep up with that envelope as we go. Make sure that that air barrier is continuous all the way around so that we don't get to the end and fail. There's an air sealing table in here in the code that they have to follow. And so these details are all supposed to be on the plans of where to seal. If they do all of this, they're going to pass that blower door test. And all you're going to get is that report at final saying, yep, pass the blower door test, right? And so a couple places that I want to talk about where I see people messing up their thermal envelope. One is allowing air permeable insulation as a sealant. So around doors and windows, I see batt insulation used a lot. That works as a great filter, but it doesn't seal air. So be sure that, if it's part of the thermal envelope, that we're not allowing batt insulation as that air sealant. We're making sure that it's something, backer rod or foam or some other thing that allows air sealing and not just air filtering. I also notice on attic knee walls that they're not getting their air barrier. So an attic knee wall is actually an exterior wall. One side is unconditioned space and the other side is conditioned space. You need to have an air barrier up there. Maybe it would also hold the insulation where it's supposed to be. But I do notice a lot of attic knee walls not getting an air barrier on them. And then I also see cantilevered floors getting missed because there's not a lot of floors that have to meet code residentially, but we just need to make sure that anything over outside air or anything over unconditioned space gets its air barrier and air sealing. So making sure that all of these places are covered. That's some place that I see get missed a lot. And sealing between the house and the garage. Even if you're conditioning the garage, the code requires a thermal isolation between the two so that we're not sucking in garage air into the house. Plus that garage door is pretty leaky. And so if I'm trying to do a blower door and pass it and I don't have a good sealant between the two, it's going to be harder to pass that blower door test for the house. And then I also noticed that a lot of people, when you have a tub or shower on an exterior wall, aren't getting your air barrier on there. So the tub gets set and no air barrier gets back there. Somebody might put insulation, but they're not getting an air barrier. So it's getting a lot of leakage in there. So you're going to get moisture, you're going to get condensation, you're going to get the insulation not working well. So making sure wherever you have a tub or shower, that I always walk through on a rough inspection where I see a tub and this is the common thing that I'm seeing, thermoply slapped in place. Then they can come set their tub and then they can still insulate behind it later, but get that air barrier and air sealing before the tub makes it in, then it's much easier to do. And electric boxes. It's amazing how much air when you turn a blower door on and it's sucking all the air out of the house. And so air is being forced in somewhere else. How much of that air is coming from the attic, down the wall, and through that electric box. So making sure that that electric box is getting sealed, because when a blower door isn't running, the air is moving the other direction. So any air that I have in the house and any moisture that I have in the house is getting into my walls through the electric boxes the other way, right? So we just really want to make sure that those are getting sealed. Those are a lot of the places that I find problems with. I want to bring your attention to 2021 Duct Requirements, where it was revised. The basic intent here is to say, if I have a duct in my exterior wall or in a floor over unconditioned space, I really need to make sure that I'm separating that duct from that unconditioned space. A lot of paths, like a performance path or an ERI path, give you a better trade. I can get out of stuff if I say that all my ducts are in conditioned space. The only way to do that is to make sure there's insulation and air barrier between the duct and the conditioned space or unconditioned space. I have to have an air barrier and insulation, or else my ducts are considered to be in the unconditioned space. So this new section in the code that really specifies whether it's in a wall, a floor, underground, in the concrete, under a slab, whatever, how to call it in conditioned space and how to insulate it. So some new requirements there. Really look at the plans, because if they are getting a credit for, which is probably one of the biggest credits you can get, is for ducts in conditioned space when you're going performance. Plus you don't have, and well, now you do. So there's a big credit for that. So make sure that you're really looking for that, because you want to make sure that they have an air barrier and insulation under it. And then I just want to bring your attention to the fact that all ducts have to be tested now. It used to be only only the ones in unconditioned space. In 2021, you have to test all ducts. They don't want ducts leaking even from condition to condition, because you're just moving air where it doesn't need to go if the ducts are leaking. So ducts within the thermal envelope can leak more, a little bit higher, 4 cubic CFM, and outside the envelope, or 8 CFM inside the envelope, 4 CFM outside the envelope. So they can leak a little bit more, but they still have to be tested. So that is new for 2021. Look for that duct test report for all ducts. Lighting, this is new for 2021. 100% of the lights have to be high efficacy. So you're looking for 100% of those light bulbs to be highly efficient light bulbs. And then you're looking for controls. There's a new section that's brought in to require either a dimmer, an occupancy sensor, or some other control that's built into the fixture to be installed for the lighting. There's exceptions for bathrooms and hallways and exterior lights, but then exterior lights also has a new section in the residential code that says if you use more than 30 watts outside, you also have to have those on a control. So some new requirements for lighting to make sure that you're inspecting for that. Whew, that was residential. It takes most of the time. Commercial is really about internal loads. It never had a big focus on the commercial envelope until 2021, and now it does. So it's really about controlling things and shutting them down when we're not needed, and to keep that mindset that whatever happens with mechanical is affected by the envelope, which is affected by the lighting. All of them work together. There's, I can only put in a certain amount of windows before I have to put in a certain amount of lighting controls. I can only have a certain amount of windows before it'll affect my mechanical equipment. So there's all kinds of, you just have to keep that mindset. And then also the idea, same as residential, stick to a path. If they don't pass it, there's another path that they can choose, but don't make them go through more. I often see on commercial where a jurisdiction will require a Comcheck no matter what. Comcheck is for one path of compliance. And so if they go that path, yes, they need to turn in a Comcheck or something similar. But if they go prescriptive, they don't need a Comcheck. If they go performance, they don't need a Comcheck. So making sure that they're only going by one path, make sure that you're inspecting from those documents that based on the path they chose. There's 3 different, they can go with ASHRAE 90.1, they can go with the IECC prescriptive, or they can go performance. So making sure you know what they chose so that you are inspecting from the right documents. What about Comcheck? Comcheck fits in here in this prescriptive path, but it's an alternative to prescriptive. So Comcheck is great. You can review from Comcheck. They're allowed to trade off in Comcheck, but only in the envelope. There is a mechanical and lighting report that shows up in Comcheck, which is just a mirror image of the plans. So if the Comcheck says there's 3 water heaters and 4 mechanical units, that better be what the plans show, because they're supposed to be exactly the same. So you can inspect from the Comcheck. It has inspection checklists. Those are great too. But on the envelope part is where they're allowed to trade things off. So just making sure that you're really looking for whatever that says. They're going through their building this Comcheck based on what they're going to put in the house or put into the building. So what kind of roof? Is it insulation above deck? Is it an attic? What kind of, they're building all this, they're building inside Comcheck and telling it, what height of insulation and everything. So then Comcheck is forming that report that you inspect on based on what they said, and it should mirror the plans. Some things about windows that have changed a little bit. It used to be, that if it was a metal frame window, it could have a worse U factor. Vinyl had better. Now it's about, is it a fixed window? Is it an operable window? What kind of window do we have? And so that's new for the 18 and the 2021. But now solar heat gain used to be a worse window on the northeast, south, and west than other faces, or than worse window on the north than you can have on the southeast and west, and now it's the same. Is it fixed or operable? Fixed windows have a lower number than operable. Operable has moving parts. So, and then projection factor. This is something that inspectors need to pay attention to. People can get a break, and this is their U factor, but people can get a break. They can only put in so much windows. They're only allowed 30% of their building to be windows. So if you see a building with this much windows, you can bet they're supposed to go performance. So you should be looking for a performance report that tells you what they're doing. They can go up to 40% as long as they put in some proper lighting controls. So if they have 40%, then you're looking for the right lighting controls. And so that's just the same thing. What I want to point out to you is to be looking for those projections, because a lot of times they'll give themselves credit for a projection. If they put a projection over the window, they can have a worse window because they're blocking some of that solar heat. So they might tell you they're putting in a projection, and then you get out there and they don't put in one at all. We need to know that. Because we need to, then they need to put in a better window. So that's just something you can usually see it on a Comcheck. It'll tell you that under their window description that there's a PF, and it'll tell you how big that PF is. The bigger the projection over the seal height, the bigger the PF, projection factor. So just really want to pay attention to that and let the plan reviewers know if they aren't putting in the projections like they said they were going to. Air barriers have always been something required in the code, but just not really. Each cycle, it gets a little bit more specific on what you can do, on what counts as an air barrier, as long as all the joints and seams are sealed. And so it's walked you through, you know, different materials that can be considered air barriers as long as you seal all the joints and seams. So that's what you're looking for. However, some of that you might be relieved of some of that duty right now because, and then if you have concrete or CMUs blocks, these are permeable. So it always asks you for, you know, some type of coating on them to be your air barrier. Well, the code had realized that maybe everybody isn't looking at it as close as we should, and realizing that maybe we need a tighter envelope for the commercial, just like we do residential. So it brought in the requirements now that air leakage testing is in commercial buildings, which it wasn't before. So dwelling and sleeping units have one test, and then everything else is dependent on the climate zone and the size of the buildings on whether it has to be tested. So not every commercial building has to be tested. Every dwelling unit or sleeping unit has to be tested, but everything else might need to be tested depending on the size. So you might be looking for, make sure you look at that plan to see if they say you need to be collecting a report. But one thing that all buildings get is the air barrier has to be commissioned, right? So somebody has to provide a report to the code official that says that they verified the air barrier as it's being installed. And so there's an air barrier on the foundation, there's an air barrier on the, you know, the walls, the ceiling, the whole thermal envelope. So somebody has to be seeing that as it's being installed and say that they saw it and verify it. Now it can be the code official if your jurisdiction decides that you guys want to do that, but most likely it's going to be a third party and they have to turn in a report that says somebody verified that that air barrier was continuous and installed correctly. So that is new and maybe save you some inspections because somebody else is doing it. But also making sure in line with that is we have these restaurants that want these big, you know, doors to open to the outside, which is great, provides a good environment, it's fun, but it also wastes a lot of energy. If I'm cooling this room to 70 degrees and it's 100 degrees outside, all I'm doing is cooling the outdoors, right? And so there's requirements now that these doors be interlocked with the mechanical system. So it's important that that you're looking for that as a mechanic, as whether that's the it depends on which inspector is going to be looking at that. It's hard to know, probably a mechanical inspector, to look to make sure that that is tied into the mechanical system so that when it opens, it shuts the heating back or the cooling back within 10 minutes of the door opening. So that's a new requirement in 2021 to be inspecting for. Mechanical and water heating is really about control issues. It's put everything in the way that that mechanical code tells you, but shut it down when it's not needed, right? How much air I need to bring into the building, we're going to design for the mechanical load, for the occupancy, the occupant load. We're going to design according to the mechanical load, but we're going to provide controls to shut it down when I don't need that many people, that much air brought in. Because if you think about it, these buildings, huge commercial buildings, have much more requirements for ventilation based on occupant load. And so they're bringing in tons of 100-degree weather. So the air conditioner is running 10 times more, right? And so we're trying to say, let's not have that happen. Let's only bring in as much air as we need so that that equipment is running so much. We're going to design for maximum, but we're going to control for minimum. So that's the idea behind the energy code. 75% of that, 75% of the entire energy code is designed to keep that mechanical system running as little as possible, because that's where you're building. So just keeping that in mind, that's why there's new requirements for demand control ventilation. That's meeting the demand. It used to be based on an occupant load, and big occupancy rooms like a big conference room or a education room or places where you had a higher occupant load, you had to put in demand control ventilation. It's a sensor that senses a CO sensor that senses how many people are in there and says, okay, instead of maybe the room holds 100 people, but there's only 10 in here. So I'm going to look for a sensor to make sure that I'm only bringing in enough ventilation for 10 people, not 100, right? Well, now they've changed it to be any like single zone system has to have demand control ventilation. So you really want to pay attention to that change, because this is probably one of the highest impact items for commercial building, is controlling the amount of ventilation that comes in at outside air temperatures. And then putting in the right size equipment, all new tables in there. So making sure that whatever the plan said, if they said they're putting in a 95% efficient or this COP or this whatever, there's all different kinds of energy efficiency measures. So whatever the plan said, hopefully that got reviewed and approved, that's actually what they put in. And then heating and cooling system controls. Does it have the right deadband so it's not simultaneously heating and cooling together all the time? Does it have overlap? Does it have the right startup or stop controls or sequence of operations? It's controlling when that air kicks on and kicks off so that we are have better control over those energy bills and the energy use. Economizers are huge. In a lot of the buildings that I see, 90% of them have economizers, but about 10% of them are hooked up correctly, right? That's free air. So if it's 100 degrees outside, I'm running my air conditioner. But in Colorado, the temperature might drop. And so it might be 50 degrees out at night. Why am I running an air conditioner to cool it to 70 degrees when the outside air is 50 or 60? I should bring in that outside air. That's what an economizer does. But a lot of times it's not hooked up at all, or it's not hooked up correctly and it's not working. This is a huge energy saver right here. So please be looking for that. And then outside controls, right? If I have a boiler that's running a bunch of snow melt, I want to make sure that boiler shuts off when the snow can melt itself because the temperature outside is warm enough. Or if I have a bunch of heating outside the building, is it on a sensor or some kind of control? So there's much is running when nobody's out there. But there's all kinds of things that we could be looking at, and it's really important for the inspector to be looking for those things if they got called on the plan. Lighting is huge. Lighting is one of those places that gets missed a lot. There are new requirements in there. You know, that in a big warehouse, every aisle should have its own lighting control to shut the lights off on each aisle so that we're not, you know, running, or to turn the lights on actually on each aisle. So if you go down an aisle, the lights turn on, but not for the whole warehouse. Same with office spaces. If nobody's here, but there's one person way over here, why are we lighting the whole place? Right? So there's requirements now to make sure that we're just not overdoing it. There's also some new requirements for some occupancy sensors in hallways. It's brought in line with the IBC. It doesn't affect egress. It doesn't affect safety lighting, but there are some things in there to be aware of. So really looking at those lighting controls in all of those spaces. Again, office spaces got a little bit of a revamp in 2021. So looking for that, and then making sure that they're set to go off after 20 minutes. And to make sure that they get commissioned. If nothing else, please make sure that your lighting controls get commissioned, get functionally tested. If you have a requirement for an occupancy sensor and a daylight responsive control and a something else, like, are they working together? Are they doing okay? Somebody needs to be looking at these things, because no matter, everybody that I talk to says lighting controls aren't working. Every lighting commissioning agent out there says they're doing it wrong. It's not working. And so something that you have to decide in your jurisdiction is who looks at lighting controls, right? I'm an electrical inspector. I inspect to the NEC because that's what I'm licensed to. Well, I'm a building inspector. That's electrical. 9 times out of 10, nobody's looking at it. So at a minimum, look for functional testing so that we can make sure that they're tested to work properly, right? There's a lot of new requirements in there, especially for, you know, atriums and primary side lit zones and daylighting controls and all of that. We're not going to go into all of that, but who's looking at that, right? The plan reviewer will be looking at, you know, to make sure that all the zones are covered, but are you looking for that sensor? Are you looking for that daylight control? If not, who is, right? They probably, in order, there's very few times when a daylight sensor is required, but you know, if they put in more windows than they were allowed, they have to do this. Or skylight, there's skylight requirements, or if they have real poor lighting, they have to do this. So they only have to do this under a certain requirement. So be sure you're looking for it. And then new to 2021, this is going to be fun to inspect, right? They have to have controlled outlets. 50% of the outlets have to be controlled outlets, whether that's every other one or 50% of each particular outlet is controlled to shut down when the business is closed. So that's something that you have to be looking for, is those controlled outlets. And then also new to 2021 is a mandatory requirement for energy monitoring systems, right? There has to be, if it's a new building with a gross condition floor over 25,000 square feet, they have to, with some exceptions for R2 and some other things, but they have to have energy monitoring system that monitors the energy use of that building. And so is that set up? What does that look like? How are you going to inspect for that? What kind of reports are you going to get? Those are things that have to be decided now. So be on the lookout for that. All right, there's a couple resources. That is the highest overview that I could give you to fit residential and commercial into one thing. As Erica talked about, that toolkit with our code helpline, that code helpline is for all codes, not just energy code. So be sure to use that hotline. You'll get an answer within a day or two from somebody on your code question. Buildingscience.com is a great website to go to that really talks about air tightness and the importance of tight buildings, and about all the different layers of assemblies, so that you can go in there and see, you know, how should this wall really look, or how should this roof assembly really look, so that you're inspecting it. Construction Instruction, they have a free app that gives you videos and all kinds of things about anything, air infiltration, leakage, ducts, anything building science related, dealing with construction. Amazing. And they're based out of Denver now. So construction instruction free. It's amazing. Energycodes.gov. That's where you could download ResCheck or Comcheck, but that's also, they have some great resources on there about how to verify energy in a building based on assemblies. And then one thing I want to point out is make sure you're always going to ICC's Errata Central, because if you're looking at a code book, I guarantee you it's changed 10 times over already. That 2021 IECC has so many errata. They print it and then find an error and then print it and then find an error. So be sure you're pulling up the errata and inspecting off the errata and not the original printing. Phew, aircom.
Just in time, right at the hour. Thank you, Shauna. Appreciate it.
Yeah.
We do have a couple questions for you in Q&A. First one, does the ERV need to have a motor or not?
Do what? Does the ERV need to have a motor?
Yep.
Maybe I'm misunderstanding the question, because I don't know how the ERV will work without a motor. In order for it to recover the energy, it has to run that air across that heat exchanger and push it through. I don't know if I'm misunderstanding the question, but I don't know how it would work without a motor to recover the energy.
If whoever posted that question wants to raise their hand, we can hopefully help clarify further for you. But I'll move on to the next one in the meantime. Does the checklist for Comcheck need to be completed at the time of submittal?
You know, some jurisdictions require that. Really, to be honest, it's an inspection checklist, right? So what happens is they should turn it in, but a lot of people require the designer to go through and fill it out. But that's not how it works. The designer isn't checking off everything you should look at. It won't show up on the checklist if it doesn't apply to you, because the program sees how you designed the building, prints your report, and then says, based on how you design the building, here's all the things you need to inspect to, and it only puts the stuff on there that apply to you. So it's really to be filled out by the inspector, not the designer. I do see a lot of jurisdictions making the designer go through and check what applies. It all applies based on what they just put into the software.
Thank you, Shauna. Those are all the questions that we have right now. So I'm going to go ahead and end the webinar, and thank you to everyone for attending today.
Thank you.